Okay, so we're trying to do number 71 and 10.4. Okay, which is this one, right? Okay. All right, so we want to measure a pipe, right? Okay, so what kind of problem is this? Okay, it's a word problem, which means my first step is don't panic. Don't. Don't is crucial.
I said panic. We're doing the distance thing that we did Monday.
Yeah, so there's the distance thing that we did Monday on here. So let's see. First things first, take a deep breath, relax, right? Draw a little stick figure if you need to or something. I guess he's in water. Okay, so draw a little picture to calm ourselves down, right? They drew most of it, so we don't need to do much. Then we should read it. Okay, so reading it, we've got a pipe cleaning firm contracted to clean a pipe buried in a lake. Okay. Whatever. Access points to the pipe are at A and B on the edge of the lake. Okay, so they've got A and B on the edge of the lake, and presumably our guy is swimming over the top of the pipe. Right? Okay. The contractor placed a stake and then measured the coordinates from reference point A and B. Okay, so he put a stake in the ground here, right? And then he measured out A and B somehow. I'm guessing really kind of instead of reading X and Y here, maybe we should read like north and east or something. Does that make better sense maybe? Okay, and then let's see. So the coordinates of A and B are these two things. Okay, cool. And I'm supposed to find the distance between A and B, right? Okay, so the distance between A and B is where on the picture? Can I see that? See, so A is here, right? B is there. A and B are that far apart, right? Okay, so I want to find out about this length here. Right? Just means that we're listing two things, right? There's two coordinates, and this one goes with A, this one goes with B. Irrespectively is when their orders are reversed. John and Tim's hair are respectively brown and blue. Whose hair is blue? Tim. Cool. Perfect English class today. All right, so let's see. I need to find this distance, right? But they gave me coordinates, so what should I use?
The formula.
Yeah, I could either use the formula or I can draw the Pythagorean theorem in here. You guys want to draw the Pythagorean theorem in here or use the formula? Okay, let's use the formula. They're the same thing, right? Because that's where we got the formula. Okay, so the blue D equals, all right, what's my formula read?
A plus, what? A squared plus B? No, the other one.
That's the Pythagorean theorem. So this is,
2 minus
Oh.
plus
see, so I need a x2 minus x1 squared plus y2 minus y1 squared. And then I need to square the whole thing. I think the ones and twos were backwards yesterday when I gave you this, right? It doesn't matter, so pick one. Okay, so let's see. I need to interpret this in the context of my problem, right? Okay, so what are these guys? What should I think when I look at 37.8 and 29.6? Would it matter if I picked x2 and y2? No. Pick one, doesn't matter.
There.
I'm going to call these x2 and y2. Just because for me it's easier to do bigger numbers as the second point and smaller numbers as the first point. But whatever, right? So on this guy, I'm going to look at this and I'm going to think this is what and what? Yeah, these are x1 and y1. Cool. All right, so what's x2 minus y1? What's x2? Okay, so I've got 37.8, and I'm subtracting 3.0. And then I'm squaring that thing, and then I'm adding. What are the y's? 29.6, and I'm subtracting 5.2. And I should be squaring that thing. So I get the square root of, let's see, what's 37.8 minus 3? 34.8. Should be squaring that and adding, what's 29.6 minus 5.2? 24 something? 4. So 24.4, and I should be squaring that as well. Okay, then what? Cram in a calculator, right? Don't do the bad rooting thing, right? What's the false rooting thing that you want to do? Kind of cancel the root and the squares, right? But that doesn't work. That would be just adding the distances. That would be saying this far is over to here plus that, which it's definitely not, right? It's definitely shorter. So if I want to punch this in a calculator, how do I do that? Okay, so I get the square root key going, right? That gives me this. Then what?
Put the 34 parentheses.
So then I put in another parenthesis? Okay. So I want 34.8, and then what do I want to do to 34.8? Square it. So there's a little square key, right? So I push that. Then I push plus.
We don't want to do a parentheses there, so it's separate or keep it in?
It's already separate. It's going to square the thing in parentheses. Yeah, no, that won't make any difference at all. This set of parentheses isn't necessary. Why? Because I'm squaring the thing first. There's no operation done in here, right? Okay, see that? So whether I have these or not, it still tells the calculator to square 34.8. You guys with me on that? Okay. This one still squares 24.4 regardless. So I don't need either set of parentheses there. What else have I forgotten? Yeah, I should probably close this thing. Do I really need that? It depends on how your calculator works. At least this way I know for sure it's going to take all this stuff and do it first, right? And then it's going to square it. So what'd you guys get? 42.5? I'm guessing you didn't come out exactly 42.5.
42.50176.467.
Yeah.
So they're little.
So approximately, right? And did I round to the degree they told me to?
The what? The nearest tenth of the leader.
They said nearest tenth. Nearest tenth. I should probably attach some units because this is an applied problem, right? This is a word problem. So in answering my word problem, there should be a
Meter.
meters and a
Sentence.
sentence, right? Somebody asked me a question, right? So what do I say?
I'm just gonna say
The distance.
Yeah. So I say the distance is approximately 42.5 meters. Period. Cool. Good.
But we're not gonna do this on the test, right? Because we're not gonna use this. We said we don't use this.
Oh, yeah, you don't need that for the test.